Hi, Algebra 2. Today we are going to talk about Chapter 1, Section 4, which is solving absolute value equations. You might have done this before, but let's just go over a couple things and some practice problems too. So, first, what is an absolute value? This is a number's distance from 0. It is always positive. We represent it with these bars, just vertical bars. The absolute value of -2, the distance from 0 of -2 is +2, but the absolute value of +2 is also +2. Your number is always positive. Absolute value bars are also included in the P of PEMDAS, in parentheses, the grouping symbols. So they are included in that step. Now you may get 0 or 1 or 2 solutions when you solve, and it's very important that you always check your answers, because you may have found an extraneous solution, a solution that when we algebraically solve these out, we get an answer. But when we go and plug it back in, because of the absolute value bars and just how the negatives and positives work together, it's not actually an answer. So let's go through a couple examples today. Let's first solve 9 is equal to the absolute value of x plus 12. Now, what we need to do with these equations, this is a very simple one to start, is remember this definition. Absolute value is the distance from 0. It's always positive. And we have these two situations. If my output is 2 from an absolute value set, I could have had a -2 on the inside, or I could have had a +2. I don't know which, so I have to consider both. So in this case, I am going to solve two equations. I'm going to say, well, what if the x plus 12 on the inside does equal that +9? And then my absolute value would be 9. Or what if it equaled -9? That is the question. It could have equaled -9, and then with the absolute value bars, I solve it out, I would still get my +9. So let's check both of these. I am going to subtract 12, really from everything here. That's the same step I need to take. Over here, I get -3, equaling my x value, and over here, I get -21. These are my two answers, I think, right now. I'm going to go over here and check just to be certain, but easy one like this, I'm thinking things are going to work out for me. I am looking for this equation and this equation to be true, so let's take a look. I have 12 plus -3. I know that is +9. Absolute value of +9 is 9. So life is good, meaning this guy definitely is an answer. I go over to this other side, -21 plus 12. I see that that gets me the absolute value of -9, but I know the absolute value of -9 is +9, so this one works out for me too. So both of these are our answers. There we go. Let's talk about another one, a little more challenging this time. I would like us to solve absolute value of 3x minus 2 plus 8 on the outside of the absolute value. Whole thing equals 1. That is the goal. So with these, you always want to isolate the absolute value first. So I need to get this part all by itself before I break it apart into the two different equations. So what I'm going to do is subtract 8 off to the other side. I get the absolute value of 3x minus 2 equaling -7. Now the problem with this, we said up at the top in our definition that absolute value is always positive. Therefore, can I actually get -7 as my answer? The answer is no. Therefore, there is no number that is going to make this a true statement. Therefore, our solution is the empty set. You might have also heard it called the null set. Or maybe you've seen this symbol before, the circle with the line through it. It just means there are no solutions. So I will accept any of those answers on a quiz, on a test, homework, all that good stuff. So just be aware of that. My absolute value bars have to equal a positive thing to actually be solved. Let's go for one more example. This one I would like us to solve. Let's do 2 times the absolute value of x plus 1 minus x equals 3x minus 4. There we go. Okay, so like I said, on example 2, our first order of business is getting the absolute value bars isolated. So I need the x plus 1 all by itself. So I'm going to add x to the other side. So I have 2 absolute value of x plus 1 equaling 2x minus 4. I am multiplying that 2 by the absolute value, so I'm going to divide by 2 to get rid of it there. Divide by 2. Absolute value of x plus 1 equaling, don't forget over here I need to divide both pieces, both terms separately by 2. So I'm going to get x minus 2. So now I'm at the point where I have my absolute value bars isolated. I can say whatever was on the inside could equal the positive version of x minus 2 or the negative version of x minus 2. Here's how we're going to split that apart. I'm going to say x plus 1 could have equaled just straight x minus 2. Nothing different about that. Or, a little longer stem there, x plus 1 could have equaled the negative version of x minus 2. Make sure you put those parentheses there because first order of business here is we are going to distribute that negative. So I have x plus 1 equaling negative x plus 2. So now I have 2 equations, no parentheses, no absolute value bars. Now I can solve both of these. I am going to work over here first. I'm going to subtract that. Oh, I just realized I made a mistake. Hold on. Let's back up. Over here, I should have had 4x. So let's rewrite this. 4x minus 4. And then when I divide by 2, I get 2x minus 2. So that's a 2x. And this is a negative 2x. Whew, okay, there we go. Let's try this again. We are going to subtract x. We have 1 equaling x minus 2. I'm going to add this 2 to the other side. I get my x value, supposedly, maybe, hopefully, can be 3. I'm going to check that in a minute. And then over here, I'm going to add this negative 2x. I'm going to add a positive 2x. Off to the other side, I get 3x plus 1 equals 2. I'm going to subtract that 1. I get 3x is equal to 1. Last step, divide by 3. I get that x is equal to 1/3. Hopefully, supposedly, we will find out shortly. So what I'm going to do now is just slide the page up a little bit. We need to test both of these answers in the original problem. So I'm just going to do a quick check. I'm going to rewrite this so I can see it. Always go back to the original. Always go back to the original equation for this checking part. So let's try 3 first. When I try 3, I get 2 times the absolute value of 3 plus 1 minus 3 equals 3 times 3 minus 4. Following my order of operations here, on either side of my equation, absolute value of 4, I just get 4. Hey, that's nice. Therefore, x equaling 3 is a valid answer for me. That's good. Now let's check x equaling 1/3. I have 2, absolute value of 1/3 plus 1 minus 1/3 equals 3 times 1/3 minus 4. So I'm going to have 2, and I'm going to go for fractions here. 1 is really 3 over 3. So I have the absolute value of 4/3 minus 1/3 equals 3 times 1/3 is just 1 minus 4. Absolute value of 4/3 is just 4/3 minus 1/3. I have a negative 3 over here. I'm going to make this 2 over 1 to make my calculations easy. I see that I'm going to get 8/3 minus 1/3 should give me negative 3. This is going to be 7/3, which definitely does not equal negative 3. So this is not true at any given time. Therefore, x equaling negative 3 is not an option for us. So my one and only answer is x equaling negative 3. So there you go, a couple equations about absolute value equations. then practice with those, and we will talk about these a little bit more in class very soon.